There's a planet. Why? Started. Why I think that's going to make things better. No, it's what is happening? Why? All right, give me a second. My computer's freaking the shit out. Let's all hope. All right, come on, computer. There we go. What is all this other stuff? I have no idea. I'm not going to care. Do you guys see my canvas now? Okay. Yay. All right. If you go to the homework sheet, you'll notice update. I kind of promised you I would try to get this updated. There you go. The sections that are crossed out in green, we're not going to cover, because there are other sections in here that are vitally important. These are optional, so I need to cut those out so we can get to the vitally important ones before the semester ends. Yeah. So it's all good. I put some more in there just in case we could shove them in there and no, so we're going to take them right back out. All right. So you can see an updated date for the quiz 7. It's going to be on this Wednesday, 3/8 through 4/2. And then the last quiz is going to be 4/3 through 4/8. Do not worry, 4/9 and 4/10 will be on the final, just in case you're worried that you'll never be tested on those. You will be. All right. And also notice that the last day of class is Monday the 7th. We're going to have a review. I'm going to have a practice final put together before that and put the answers up over the weekend. And then that class Monday would be devoted to reviewing for the final. You guys with me? Okay. You're welcome. So let's see, a few more people came in. Let me reiterate a couple things. Updated homework sheet up in Canvas. Updated grades in Canvas. The grades don't count the homework. I'm hoping to program in a couple more columns that will show you what your grade would be with no homework and what your grade would be with all the homework. So you can figure out you're in the middle somewhere, okay? So hopefully that'll happen before Thanksgiving next week. We'll all find out together. All right, any questions from homework or anything? Notice the next quiz is this Wednesday. Okay, all right. No questions from homework. Jupiter and I are very confused, but we'll be okay. I'm not sure how to take that. I had a few questions during office hours, but if nobody has any questions from homework, that's a little sus. With the lingo, yeah, fellow kid. No, shut up. Thank you. It is a nice Jupiter out. All right. I'm not really sure what to make of that. I think for sure you guys must have questions, but if no questions, we'll get right back into section 4.3 and then into 4.4. All right, let's see. A few more people came in, so let me kind of slowly make my way over there. Ask me questions if you got them. All right, a few more people coming in.
Wait, I actually do have another question.
Yes.
On 4.1 applications, number 3, I was totally lost. I was reading it really late last night, but I was like, what the hell?
All right, let me get to 4.1. 4.1. Well, all right, there you are. Which number?
3.
Oh, shit. All right. All right, here it is. Yeah, so the nth triangular number, so 3-sided figure, is this. The nth square number is this, right? 4-sided. The nth pentagonal, and of course a pentagon has how many sides?
5.
And look at this, look at what they're telling you here. So this is looking at a pattern, 1n minus -1 for 3 sides, 2n minus 0 for 4 sides, 3n minus 1. See how it goes -1, 0, 1?
Mm-hmm.
So it's all about looking at the pattern.
Oh, somebody filled in my book. That's why I was so confused, because it already has the answer, I'm guessing.
Mine
Oh,
does too.
well,
Oh, okay.
that's why it's weird to me why they sell used copies of workbooks like this, because it makes no sense. All right.
Okay.
It's like printed in there though. Like they printed it in this version. It's just a different color, but they printed it.
If it's blue, you got the Magic Instructor Solutions Manual, which is interesting information for me.
I have like a green. It's like green right there.
But it's like computer generated.
No, it's the actual book.
Oh, somebody wrote in it.
No, this one's it's like
Right.
printed
So how
in
do I
there.
say this? It's not handwriting. It's typed or
Yeah, it's typed. Just
Computer
right there though in green.
so you have a different version of the Instructor Solution Manual.
I
I
have it
would hope
too.
not.
I have it too.
Well, is it everywhere? Is it every section?
No, just right
No.
there.
That is weird. Well, okay, enjoy it. We'll find out if it's the right answer. If some evil green goblin has put the wrong answers in there, that'd be. I don't know if it would be funny. It would be interesting.
We'll send
Somebody
you
with
a
way too
picture
much
of it.
time on their hands. All right, guys. That's weird. But anyway, all right. Anything else? Let me look at my book. What is this? 467. Let me see what's going on in my book. Holy shit.
Just right there, Jeff, I believe. That's it.
All right, that's yeah, anyway, it doesn't matter. I'm pretty sure. Does the answer make sense? Doesn't it follow the pattern? And if you're
No.
not sure what hexagonal means, you could Google that damn thing, right? And what's hexagonal mean?
Six-sided.
Six-sided. Right?
So I
if
understand the
five-sided-
4.
Go ahead. Sorry.
I understand the 4 in the equation, but
Sure.
what I don't understand the 2, because
All right. Now look at the look. Watch. Isn't there a -1 here?
mm-hmm.
And there is 0, which is one more. Isn't there a 1,
Okay.
which is one more?
Got it.
Sweet.
Okay.
So does that always happen? Not quite like that. Is there always a pattern? Not quite that obvious, and sometimes no pattern. But with geometry, there's very often these kind of patterns, especially, which kind of makes sense. Okay. Whew. All right. Anything else? That was a good question. That was kind of weird that they put the answer in there for you. Don't get used to it. It's in my book too, so I didn't even notice that. I don't know. The semi-helpful green gremlin that goes in and answers one question in every math book. I love it. Okay. So let's see. Where did we leave off? Notice this, that the next quiz will be on, get out of there. Here's somebody's, okay. Oh, that, thank you. Here we go. 3.8 through 4.2. Right, we just got into 4.3 last time. We basically finished it, but I'm going to review it a little bit right now. All right, so let me stop sharing that. So make sure you come, especially tomorrow, with questions from 3.8 through 4.2. So you're ready for the quiz Wednesday. Let me see where to go. There it is. So let's get back here. So here's what we did last time, right? We talked about this margin of error, and that's that plus or minus 3, plus or minus 4% that we always see. Can somebody remember, when will that error get really big if what is true? What would make the, sorry?
When the sample size is smaller.
Yeah, when n is really tiny, or the smaller n gets, the bigger the error gets. It makes sense because when you're dividing by a smaller and smaller number, your answer gets bigger and bigger. And doesn't that match with what we just already know? What's better to have, a small sample or a big sample? We already know that a big sample is better, right? And this is just the math behind that. This is just math going, oh yeah, you guys are right. We're like, thanks, man. It's just being a lot more precise about what that means. It's better. Okay, math says, here's why it's better. Okay, maybe. Okay. What's the little p hat dude? The hell is that? Little p with a party hat? What is that?
Population percentage.
Good try, but no.
The respondents are not responding.
It's not the population percentage. It is the
People that responded.
It's not the population percentage. It is the sample percentage.
Sample.
I like it. Okay, let me stop for a minute. If you're going to take statistics next, remember this. A lot of the things that a lot of the variables with stuff on their heads relate to a sample. You'll see what I mean when you get there. All right. So P with a hat on is the sample percentage. P without a hat on it is the population percentage. Okay, you guys semi with me? Doesn't it make sense that I want to have a different symbol for those two things? Because it's huge. If I know the population, I want everybody to know immediately that I know the population percentage. And that's how I show it. I just don't put a hat on it, which is not something you're used to hearing about variables. Does that variable put a hat on? I don't know. All right. It's very strange, but it's the symbol they picked. Oh, well. And also, I gave you a better symbol than 1 minus p hat. What do we call the opposite of p hat? What do we call the rest? Q hat. I love it. Right. In the book, they're going to just call it 1 minus p hat, but we know better. We know it's Q hat. Oh, shit. Am I getting laggy? No. Okay. I should probably turn Jupyter off. I will in a minute. All right. I think we got through. Yeah, we did several examples of this. And it's really just putting the stuff in the equation correctly. And like I told you, if you take statistics, you will see the reasoning behind that formula. But it's you see this everywhere, this plus or minus 3% or plus or minus 4%. So it's kind of nice to see where the hell that comes from. Let me see. So let's look at this one. Did we look at this one already? I can't remember. You begin by surveying students on your campus about their attitudes on racial relations in the U.S. After 70 surveys oh yeah, we did this one. I remember this. All right, it takes me a while. I don't know if you guys remember. I just remembered that we did this one. And then we came up with this equation. Let me see. Do they give you the equation? Let me see. Yeah, let's do this problem here with this equation. Let me remind you this equation. I got to change screens though. Hold on. Oh, let me turn Jupyter off while I'm here. Go away. There we go. Let me see. Okay, let me share screen. No, I got to move you guys over. Everybody just hang on. Bring that back over here. There we go. There we go. Okay. Then I got to plug this thing in. Hold on, everybody. All right. There he is.
Bluetooth connected.
Yeah. Holy shit. I'm going to clean this desk off. Okay. All right. So here is the formula we got last time. Let me put it up here. Let me see if this makes sense. You're about to do a survey and you want to know how many people you need to survey. So for example, this problem says, I want my error to be like 2%. I want to report something really strong. I'm only off by 2%. So you can really trust what I'm saying. And we already know that the larger the sample is, the more certain I am about what I see, the smaller my error should get. So exactly how big of a sample should I take? And I'm pretty sure last time, did we actually get to this point? We might not have. So let's do it together.
Yeah, we did. We did it.
Somebody write this
Yeah,
again. We did? Oh, we did. So we start with this guy. And then we solve for n. Maybe you're right. We got to here. So if you solve for n, it involves some dividing and squaring and multiplying and shit. You'll get to here. So that's the formula for how big of a sample you need to have a margin of error of so much. Now, what is missing in number 3? What do they not tell me in number 3? Well, let's start with this. What do they tell me? What is 11%?
The sample one. The p hat.
Sample what? Yeah, the p hat. And the q hat would be what?
0.89.
Yes. All right, is everybody else with us, right? If there's 11% chance of the one thing happening, there's 89% chance of it not happening. That only makes sense, right? Let's see. What's the error?
.02.
Beautiful. 2% is not a number. Write the number it represents, 0.02. I love it. So the only thing they don't tell me here is n, which is really the question. How many people? N. Well, I have an equation that tells me what n is. Go ahead and try to fill that equation and I'll sit here and wait. Go ahead and try to figure out what n is. Oh, I got somebody with this oh, I don't know. Maybe maybe I should do it too. Let's see. I agree with you. Well, the person who just privately messaged me, I agree with you. Anybody else get the answer yet? Oop. Yes, somebody else got the answer. Yes. All right, now you can just tell me. Anybody get the answer?
N equals 979.
979. So you would need to survey at least 979 people to be within 2%. I like it. Cool. Is everybody with me on this? And again, the thing I don't like about this, you know me. You know I love showing you where formulas come from. This is an instance where I like, you guys have already seen the plus or minus stuff everywhere. So I like showing you the math behind that. And it's a little teaser in statistics. You're actually going to figure out why the formula is that. But this at least shows you there is a formula. It's not just somebody in the back room going, "Oh, make it 4, man. Yeah, I'm not really sure. Make it 4%." No, it's an equation that tells you what it is. Let me stop. And then in the background, there's always this idea that for the problems we're doing that we're 95% confident. I don't know if you guys remember, we talked about that. So in statistics, you can say, well, what about this formula changes if I want to be 99% confident? What if I want to be a little more confident about what I'm saying? So this sounds really weird, doesn't it? You're not used to mathematics being so honest. That's why I love about statistics. Statistics says, okay, here's the formula. Here's the number you got. And there's a 5% chance that we're wrong. That's so real life. That is so real life. Some people hate it, right? They think math is supposed to give me the right answer all the time. Well, when you're dealing with unknowns, how could math give you the exact right answer? That's why all these people try to come up with mathematical ways to predict what the next lottery number is going to be. That is impossible, right? Don't trust anybody who says they found something. And it's not totally impossible because the way they randomize numbers might be. Anyway, I'm not going to get in all that. Don't go down that rabbit hole. All right, how are you all doing out there? So this is a situation where I can't show you the full derivation of it, but it ends up being a formula. You just plug this stuff into the right place in this formula. Okay, I like it. I like it. Maybe. Let me clear all that away. Pop. Blah, 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 blah. Oh, okay. So you guys do number 17. And just to help you guys out, what is the information 17 gives you that is unnecessary? What's the number they give you that doesn't mean anything to you?
$100.
Yes, good. The $100 is not going anywhere in the equation, right? It's just the situation. It's not a number we use mathematically. Oh, they actually tell you that. Look at the little math note down here. They tell you what I just told you. Yay. Oh, man.
Jeff, I've been in and out because I had a doctor's appointment on the phone. They just kind of took longer today. So sorry.
Okay. No worries. No worries. All right, guys, let me see. P hat 0.09, which means Q hat 0.91. Always make sure that these add to be 1. That just means that together they cover everything, all the possibilities. The error is 2%, so 0.02 again. So 4 times 0.09 times 0.91 divided by 0.02 square. Oh. Let me see, can I do it in my head? Jeff, why are you doing this? I don't know. 16, 160, 1600, 800. Wow. I get like 800. in my head. Let's see what I get on the calculator. Oh, okay. All right. I can live with that. So what'd you guys get?
819.
19. I apologize. I was way off. Okay, so that's not too hard, right? I mean, that's pretty simple because it's a formula that's already been created. We just have to know which numbers to put where. No worries. So let that be nice. Okay. So I'm going to clear all this away. How many of you guys would take this offer? Is $100 enough to be off your phone for a week? I like it. There you go. I had a feeling the answer would be no. All right, all right. I could do a poll about how much would be enough, but who cares? Blah, 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 blah. Okay. So the homework is going to look pretty much the same. They give you a situation. They ask you to figure out the error. How many people would you have to survey? So they're going to give you a problem like we just did with the N. Let's see. And then they do this interesting thing here. This is neat. So a lot of what we do in statistics assumes an infinite population. So this is just a correction because the population is not infinite. So for example, the US population, it's not 325 million anymore. I think it's 340 million. So whenever this book was published, more people have been created or brought in since then. Let me see. Yeah, okay. So that's what the homework's going to look basically like the stuff we've already done together, except for that one problem. I have made 4-4. I've thrown it out. So I'm really sorry. If you wanted to talk about jetpacks, you could do that on your own time. So we're shooting ahead to 4-5. And 4-5 is going to bring back an old favorite. Oh, let's do this. Yeah, I like this. All right. Ooh, look at all this. This is beautiful. So this is the prep skills that you would have done if you did 4-4 homework. So the first couple really, hopefully, are not even something we have to talk about, right? You should be able to convert from percent to decimal like we were just doing. What is 4% as a decimal?
0.04.
Yes, dear God, don't say 0.4. That's 40%. All right, I like it. Blah, blah, blah. So these first two I'm not even going to talk about. Let's see who remembers this. Number 3 and 4. Is this linear growth, exponential growth, or neither? I don't know if you guys remember those kind of questions.
Linear.
Yeah, this first one's not too bad. How do you know it's linear? Because what do you keep doing?
Getting 9.
Yeah, it's just keep adding 9. So linear is when you just keep adding the same amount, which is really the slope, right? The slope tells you how much to add to y for every one step over. I like it. What about number 4? Remember, the answer could be neither, so don't just automatically say exponential. How do you check to see if it's exponential? Who remembers?
Multiply.
Yeah, you got to see if you're multiplying the same thing, but how do you check that?
Divide.
Yes. So just up here, how'd you get the 9? You actually did 16 minus 7 and 25 minus 16. So here, to see if I keep multiplying by something, I take each one and divide by the one before it. And every time you do that, what do you come up with?
1.5.
Yeah, you can check it all the way through. Since I keep multiplying by the same amount, this would be exponential growth. And we've done that before. Hopefully some of you guys remember that. All right, I like it. Let me ask you this extra question then. what percentage do the numbers keep increasing by? So for example, this would be like me putting $2 in an account that earns what interest per year? I don't know if you guys remember. Remember how you could do 1 plus the percent, 1 plus the rate? So this increases by 50% because it's 1 plus 0.5. What's half of 2?
1.
And isn't that what they added? What's half of 3? Half of 3.
1.5.
1.5. Isn't that what they added? So every time it goes up by 50%. And I knew that because it says 1.5. So if I had another one that was 1.06, that would be an increase by 6% each time. That would be like me putting some money in a 6% account per year. I don't know if you guys remember that. You could just add 1 to the increase number and multiply by that. That was the shortcut. I don't know if you guys remember that. So I love this section because it's sort of a review of something we've done already. Let's see. Oh, and I basically just did number 5. Oh yeah, relative change. Do you guys remember how to do relative change? What do you have to figure out first to figure out what the relative change was?
Difference?
Say again?
Difference?
Yes, you got to figure out what the change was. So you have to figure out what the difference was. I love it. Right? So it'd be 35,250 minus 31,500. And then what would you divide that by to get the percent, the relative change? Do you guys remember? What do you have to divide by? Which one of these?
The original number?
Yes, good. You divide by the original. I love it. Does that sound familiar? Because it's going to be, it's based on where you were and how you got to where you are. So it's got to be based on the original. So divided by 31,500. So let's see, what is that? 250 minus 31,500 divided by 31,500. So I get almost 12%. I get 11.9%. It's a pretty damn good raise. All right, maybe. Okay. Let's see. All right, here's a neat one. If any of you guys take any prescription drugs, right? Like me, I've got to take something for my neck because I had neck injuries when I was younger. Several stupid things I did. So over time, the amount of the drug that's in my bloodstream decreases. And when it gets past a certain point, the pain comes back. So this is kind of like what this is all about. If I administer a drug to a patient, it will over time decrease. Oh shit, you can't even see the bottom of this. That sucks. I'm gonna have to clear all this stuff. Anybody still copying stuff down?
We can see.
All right, here we go. Oh, huh? Sorry.
We can see.
You can't even see the, you can't see the x-axis scale. Do you see what I mean? If you're following along with me, I don't know. Hopefully everybody's got a book, but let me clear this. It's going to go way by. Let me bring, now we can see it. There we go. What was the, oh shit, now I can't see anything. What was the original concentration? And of course, that would be the what of this graph. To find the original concentration, that technically would be finding the what?
Y-intercept.
Y-intercept, kick ass. So what was it?
0.010.
Yeah, so the actual original concentration would be 10 milligrams per liter. And is this linear decrease? Is this a linear decrease? So this time it's much easier than the question before. Go ahead, Vu.
No, it's not.
Yeah, you can tell it's freaking curved. I don't need to do all the stuff we did up here in 3 and 4 because I can just see it. It's not linear. It looks like it's probably exponential, but I'd have to do some more work to figure that out. How long did it take for it to drop below 4? Well, that's not too bad. I just find 4. So about how long did it take to drop below 4? A little more than what? At 10 hours. Where is it at 10 hours? What's the concentration?
A little bit above 4.
A little bit above 4. So of course, how long did it take for it to drop below 4? A little bit more than 10. A bit after 10 hours. So now look here. This is what I was talking about right here. Jeff needs a concentration of at least 2 milligrams per liter for the drug to be effective, or else he's a complete jackass. About how long was this dose effective? I love that question by itself. Let me take all my little markings out of there. Don't say anything out loud. Think about this question. Part C. Don't say anything. This time, give me an estimate.
About 16 hours.
Yeah, maybe. So what's right in the middle here? If that's 15 and that's 20, what time is right here? What's right in the middle of 15 and 20?
17.18.
17.5?
Yeah.
So I would estimate this would be maybe more like 18 or 18 and a half, or right? To be conservative, I would say 18. So probably every 18 hours, I should re-up this drug. You with me? For the drug I take, it's roughly here. It's roughly 20. It's not quite 24 hours, which kind of sucks, but oh well. I just deal with it. That's for me. Sorry. Let me get out of here. It has nothing to do with this problem. So this one, he would have to take the drug roughly every 18 hours just to make sure it's still in an area that's effective. Okay, maybe. You guys with me? Okay. Any of you guys going on to be anybody want to be a nurse or something? Anybody working towards that? Not really? No? So this would be the kind of thing, obviously a doctor would worry about it, but a nurse would worry about this also. All right, let me see. Let me clear all this away. Pop! All right, so what this section's all about, if you couldn't tell already, is about exponential growth and also a little bit about function notation. I forgot to look. I feel like we've talked about function notation before, but maybe I'm remembering some other class. All right, here we go. Blah, 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 whatever. Let's look at this one. Sometimes I don't like their questions. Let's see. If most people won 15,000 on a game show, they go on a spending spree, but not you. I don't know about that. If I won $15,000 right now, I think I'd have some fun with that thing. Too smart for that. Well, sure. You invest it, blah, 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 40 years, dude. So they've done all the work already. So you put $15,000 into did they tell you? They don't tell you. Good. So that's probably what they're going to ask you. Do we know how much money, what the percent rate is on this? What the rate, the percentage, the interest rate is on this thing? Could we figure that out? Let me see. So that's basically number 2. So do what they say to do in number 2. Make sure to do a couple just to be sure that you're right. Yeah, I like it. I like it. You guys understand what's happening? Yes, okay. What, all right, now tell me, anybody found something interesting?
7% interest rate.
I like it. So when you divide, you get 1.07. Anybody find any that aren't exactly 1.07? Like I did this one here, and it was like 1.0700000214. That's basically 1.07. Why might some of these divisions not come out to be exactly this? So it is a 7% account. So
This money is rounded off.
beautiful. Exactly. We round money off to 2 places because that's as far as our money gets broken down, right? Into pennies. We can't cut a penny in half. Well, you can, but you're not going to be able to do much with it. We don't have any half pennies. We're not England. Right. All right. Tuppence a bag. All right, stop. Is everybody cool with this so far? And I love this because it's reviewing this idea of the shortcut for 7% rate is to multiply by 1.07. We talked about that a long time ago. It's bringing back the idea of exponential growth, which I love. Isn't that what we just proved? If this is always the same multiplier, then this is exponential growth. Exponential. Bow, bow, bow. All right. And I think what was just answer number 3. So it exhibits exponential growth. I like it, which is what you want your bank account to do. All right, let me clear all this away. All we got to do, kids, to get this is to somehow win $15,000. That's all you got to do. Right? Just that simple, easy first step, and then you're on the way. Or, have a rich parent leave that to you in their will. Blah, blah, blah. Blah, blah, blah. Oh, how much will be in the account after 10 years? Let me remind you about a couple things. So we started with $15,000. And I want to know after 10 years. And of course, it's a 1.07. I'm sorry, let me say it like this. This is 7% account. You should be able to do this in one line of work. It should not be a multiple step thing. See if anybody remembers how to do this. It's kind of giving it away up here. All right, does anyone know how to set this up? What would it look like to figure this out?
Use a 10th power,
Yeah. And what goes in here?
the percentage.
Exactly how? Just 0.07?
No, just with the 1.
Good. All right, I like it. Thank you. And then, whatever the hell you get. I don't know. Let's see. Shit. All right, so I get $29,507.27 rounding. That old adage about you have to have money to make money. Okay. blah, 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 blah. Now, here comes the interesting. Do number 6. Read number 6 and try it. I'll sit here and wait.
It's a kangaroo.
This?
Kangaroo eating a carrot.
How you're in my head. That's perfect. That's exactly right.
No, you're
All
just a good artist.
Yeah. Yeah. All right. So let's see what we got. So here's what it looks like when it's specifically 10 years. So what will this look like after X years?
10 becomes an X.
Yeah, it's crazy. So I've shown you that idea several times this semester. If you give yourself a number, and that's what number 5 did, it gave me a 10. Then it said, what if it was X years? Well, then you just put an X in the place of the years that you knew for a second, right? I don't know how many years, but I know where to put the number of years. I put it in the power. So another way to write this, now somebody tell me, I feel really bad that I don't even remember if we've done this yet. I could write this in function notation. I would write this like this. F of X equals. Have we talked about this at all?
No, I don't think so.
No. Has anybody ever seen that notation before?
Like in Excel?
Oh, I like it. Yes, Excel uses that kind of notation. I agree. But not only in Excel, it's everywhere. So so I think what I'll do, all right, I've got a handout that I think we'll work on tomorrow dealing with functions, but just to show you. So let me take this up here. So given this function here, here's one reason why we have this notation. Notice how I read this. This is F of X. In fact, can somebody read this? Let me write it over here. Can somebody just read this for me? What does that say?
Divided by 7.
No.
Square root of
Square root of 7, right? So would it make sense? What if so what is this? This is the square root of X, right? So what if I said solve this for X? What if somebody just divided by the square root symbol? Does that make any damn sense? And they go, well, it cancels. So now I know X equals 7 divided by square root symbol. Well, that's insane, right? Are you guys semi with me? What I'm saying is, don't divide by F. That doesn't make any sense. This is not F times X. This is F of X. So what is F of 10? We've already done that. What's F of 10? It's 15,000 times 1.07 to the 10th. So F of 10 would be 29,507.27. You guys semi with me? So this notation allows me to write what the input was right there equals what the output is. So I can see what point would this function go through. What's the one point I know that this function would go through? And of course, a point Go ahead, sorry.
20, well, the number that you wrote.
What point would it go through? There's two parts to a point. What's the input?
10 and
10.
29507.
I like it. So function notation, one of the most basic and, kind of most lame, but still it's something. Things it does is it allows me to see what the input was and what the output is all in one go. All right. It does a lot more than that. So we'll get into more function stuff with that handout. Okay. I really know how to use a whole freaking screen's worth of stuff. Okay, here we go. Let me clear all this away. You guys all got that? Anybody still copying stuff down? So everybody got this here? I like it. Somebody's like, of course they got that. That beautiful stuff. All right, let me clear this away. Blah, 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 blah. Okay, look at them. Look at this one. Elaine's equation is this. What was her initial investment? Just looking at the equation.
12,500.
Kick ass. And what's the rate of the account?
5%.
5%. Okay, sweet. Done, right? Do you guys notice that the form of this, let me make this even less specific. Do you guys notice the form of this is y equals ab to the x, right? A in this case is the initial amount. B is the multiplier of how much it grows by per year. Right, grows 105% each year, right? You guys semi with me out there at all? So if something is in this form, I can tell many things about it. I can tell what was the initial amount, and I can tell how much it grows per time unit. In this case, it's years. What is, somebody help me out. Do you guys remember, what is, somebody write this way. Okay, Jeff, good job, buddy. What is f of 0? So that means put a 0 here. Oh, shit and a half. Jeff? Keep it. Put a 0 here. So what is something to the 0 power? Do you guys remember?
Just the number.
No. That would be something to the first power.
It's
What is
one.
something? Yeah, it's just 1. And how does that match up with what we know is true? Well, the initial after no years is 12,500. That makes sense because that's the initial amount. And since I make X 0 to get it, that must mean the initial amount is the y-intercept. And we kind of know the y-intercept is very often the initial amount, the starting place, right? Not all the time, but most of the time. All right. What time is it? Okay, here we go. Let me clear this. Gone. All right, so here they finally catch up to me about functions. Has anybody ever heard of a movie or a TV series called Highlander?
That was an awesome show and movie.
All right. So how does that come into play here? Notice what it says, and let me rephrase this in a much better way. A function is a relationship between two quantities, very often X and Y, right? A relationship between two variables where each input produces a unique output. So what's another way to say that? For each input, there can be only one output. There can be only one.
I saw that
Oh.
coming.
There you go. I knew it. There could be only one output. All right, now what the hell does that mean? Why does that make sense? If somebody puts money into the bank and they say, okay, how much will there be in 10 years? And the bank says, well, there'll be 1,000 and there'll be 1,500. What? There's only one. What are you talking about? If everything stays the same, how much money will there be? There can only be one output for my question about time input. So a function is something that makes sense physically. If I throw a ball and I say 2 seconds later, where's the ball? And you say 15 feet up in the air and it's on the ground. It's like, what the hell kind of ball is that? What the hell are you talking about? So for an input, time, there can be only one output, position. You guys at all with me?
Yeah.
That's one reason why we like to define certain things as being functions, is because they make sense in these kind of physical situations. There's only one possible output. Where were you on the night of January 5th? I was at the store and I was over across town. And what? Who are you? Stop it. Okay. Got that. All right, sorry. I was going to make a stupid Harry Potter joke, but I decided not to. Let me clear this. Clear. Okay. Clear. All right, they talk about Excel. Don't worry about Excel. If you have Excel, that's good for you. Excel, it's really good to know how to use it, but I'm not going to require people to have it. How many of you guys have Excel, by the way? Does that pretty, I mean, it's semi-standard, but you don't necessarily have to have it.
I have
Does
it, but
anybody-
I don't use it.
Yeah. There is some free software that I'm going to try to look into using. There's several different ones that basically act just like Excel, and they're free. But I don't know if I want to force people to download software onto the computer, but we'll see. We'll see. Blah, 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 blah. Oh, let's see. Am I interested in any of this? No. Okay. Oh yeah, this is good. This is what's getting me in the morning. I like it. So this looks a lot like, caffeine is a drug. So this looks a lot like that concentration in the bloodstream kind of thing. Yeah, after you take it in your system, the amount dissipates exponentially, assuming that you don't add more. All right. And again, I mean, do you guys understand where this is going to go? You can almost predict the questions they're going to ask. If you divide these, is it it does look like it's exponential, but now it's going to be decrease, right? It's going to be decreasing by a certain amount. In fact, let's take a second. What do you get when you divide? And be sure you divide the correct way. Can you go ahead and divide a few of these and make sure that it's exponential? Right, divide a few of these and make sure that it actually is exponential. And then I want to know what the rate of decrease is. So is anybody getting, you guys, is it seem to be proof that it's exponential?
Yes.
Now be really careful. What number are you getting that tells you that?
0.8.
Exactly. If anyone's getting 1.25, you are doing it the wrong way. You divide that divided by the one before it, always. Since this is a decrease, it makes sense that it's less than 1. Can somebody tell me what percentage it's decreasing by?
Eight.
No. So watch this real quick. I want you guys to get this. The problem we just did up there, let me see if I remember. I can't even remember what the hell it was. Was it 1.07? I can't remember. What did that mean? It was increasing by what percent each step? What percent was it actually increasing by when I got this?
7%.
7%, right? Because it's 1 plus 0.07. 0.8 is 1 minus 0.2. Are you guys with me? So what percentage is it actually decreasing by each step? 20%. If you don't believe me, what is 20% of 180? If you do it in the calculator, you get 36. And what's 180 minus 36? It's freaking 144. So it does decrease by 20% each step. So how do I see that? Well, when you saw this earlier, you know to just look at this piece and say 7%. But to be honest, it's how much one changed by. So how much did one change by to get 0.8? It changed by 0.2. That's a 20% decrease. I really want you guys to see that. So every hour you have 20% less caffeine in your system. I actually don't know if that's right. We got to look that up. We got to Google that. It's probably different depending on what your weight is and what other food you had and blah, blah, blah. Who cares? And then it's going to ask you all the normal questions, right? What's the initial amount in your system? And it's going to ask you to do what we've already done. Right? You should know by now this book is very, very repetitive, which is kind of nice. Keeps slamming the same stuff into your head. Blah, 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 blah. Who cares? All right. I think that's a good place right there. We can have a little early class today. Yeah. Because at 11 o'clock, I have to give a speech to the Senate. It's going to be exciting. I'm trying to run for Senate president. Watch out.
State Senate?
No. Grossmont's College Academic Senate. Small, start small, right? All right. There's nifty stuff ahead in this homework about exponential stuff. All right. So tomorrow I'll have the function worksheet that I talked about. We'll do a little bit with that. So this kind of stuff here is more, makes more sense. Because the next section, well, let's see, is this one I'm going to do? I don't think I'm not going to do this section. Okay. But we have to know functions. All right. So otherwise that's enough for today. Let me know if you need to hang out afterwards. Otherwise you are free to go. Everybody good?
I have a question.
Yes.
So I'm still confused what I'm doing wrong on question 4 for 3.8. It's the slope form y-intercept thingamajig. But okay, so if I have two variables and I'm trying to get y, I don't understand what I'm doing wrong.
Let's see, where am I? 3, here we go. Which one? Number
4.
Oh. All right, you were almost there. What happened? So
I don't know. I'm like
So-
going blank.
tell me again what your equation.
It
You
was
answered
y,
already. You already answered number 4.
kind of ish. I think that's the question.
No, you
Or-
totally did.
okay. Okay, but then you still need it for the other slope
number
form,
5.
so I have to
Yeah.
finish the equation.
So
But
give me the equation again for number 4. Oops, shit.
y minus 7.2 equals negative 0.12 parentheses x minus 15. Ow.
Yeah, okay, sounds good. So that's number 4. So number 5 just says solve for 1. Right, because slope intercept form is y equals cat butt, y equals stuff, right?
Drives me insane.
Sounded like you did the first step beautiful. You said you distributed that. And you got plus, right? Plus, what was it, 1.8? Or
1.8, yeah.
And what's the last thing you got to do? What's in the wrong place? How do you get y by itself?
You add the 7.2 to the other side, but that's why I'm confused. So y equals, No, stop. You're hurting me. Negative 0.12x minus or plus whatever that answer is. I'm guessing 8, 9. It's 9.
You're done.
I'm
That's
done. So,
Yep.
so then on the next thing, I'm supposed to find out the mx plus b, and how do I know what B
No,
is?
this is mx plus b, isn't it? Isn't this m
Oh my
X.
god.
plus b? So that's the power. I want you to really understand this. This is really hard for students to accept, but just by getting y by itself, everything else falls into place, right?
God. Okay. Now. Okay. Awesome.
So for example, there's actually an equation for a circle that if you get it in the right form, you can see the center and the radius. So for a line, if you get it in this form, you can see the slope and the y-intercept. You don't actually have to figure them out. You can just see them.
Okay. That's so
So
awesome.
now number 6 is going to be easier to graph that bad boy.
Wow. Okay. Awesome. Thank you.
You're welcome. All right. You guys all right out there? If you're out there still? All right, I'm out of here.